Alright, so today we're going to talk about proofs with triangle congruence. We're going to start with side, 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 and side angle sine. So, if all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using fewer parts. So, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So, this is saying if I have three sides that are congruent, then I can also say that their angles are congruent. So once we prove that a triangle is congruent, then the angles are congruent when it comes to side, side, side. So if here AB is congruent to ED and BC is congruent to EF and AC is congruent to DF, then the whole triangle ABC is congruent to triangle DEF. Okay, so the cool thing about triangle proofs is that we're going to do the same thing over and over. So as long as you're focused, paying attention, drawing and labeling, so let's write that down, drawing and labeling, then we'll be okay. It takes time. These do not come by you just seeing it once and getting it. It's going to take practice. So here we go. Number one, this is a sample side, side, side proof. So our givens, remember we always start with our givens, okay? And here they told us that PQ is congruent to ST, given. Let's also mark that PQ is congruent to ST. So these little hash marks tell me that these are congruent. QR is congruent to TR, also given. So QR is congruent to TR. And then R is the midpoint of PS, also given. Now, R here is the midpoint. Remember, if they tell me something in the midpoint, that means it cuts two segments in half. Well, that would mean that PR is congruent to RS. And look, that's what they put next. And so we would say that this is by the definition of a midpoint. And now we have three sides marked, side, 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 side. So we can say that the triangles are congruent by side, side, side. Okay? All right, let's do another one. Let's look. Our givens, that's what we start with, given. And then we mark JL is congruent to NM. K is the midpoint of JN and LM, also given. So let's look at that. K is the midpoint of JK and KN. So what we can say is that JK is congruent to KN because by the definition of a midpoint, it splits into two congruent segments. So definition of a midpoint. Now, the next one says LK is congruent to KM. Well, this is also the midpoint of LM. So that means these two are congruent. So also by the definition of a midpoint, they're congruent. So triangle JKL is congruent to triangle NKM by side, 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 because we have three sides marked on both. All right? Okay. So we're going to do another one. We're going to fill this in by ourselves. So the first thing we always start with is our givens. So here we have AC is congruent to AD, given. Mark ACAD. CB is congruent to DB, also given. Mark. Now, we talked about the other day, there's a few things you can assume in triangles or assume in general. We can assume vertical angles, we can assume the reflexive property if they're two sides that are sharing a side. If you look here, AB is congruent to itself because the triangles share that side. So we can say that AB is congruent to itself by the reflexive property. Okay? And now we have three things marked, right? We have side, side, side. So we can say that the triangles are congruent by side, side, side. Okay, now we're going to do side angle side. So the difference with side angle side is we have a side marked, an included angle, and another side. So included means it like hugs it. Okay, so here we go. If a side, so AB, is congruent to the other side, ED on the other triangle, if angle B is congruent to angle E, and then BC is congruent to EF, then the triangles are congruent. So triangle ABC is congruent to triangle DEF. So, I said this, but included means the angle between the sides. So if you look, side angle side, the angle's included. So it always has to be the angle in between the sides. Okay, so let's try this proof. We have our givens, right? We always start with our givens. So JM is congruent to LN. So JM, let's write given. JM is congruent to LN. Then they told us angle JMN is congruent to angle LMM. So let's look at this. JMN. So that is this angle right here. And then angle LNM. It's always the middle angle that's congruent. So that's N. So those are congruent because that's also given. Now, we were only given two things, so now we need to look for like the reflexive property or they share a same side. So that's hard to see sometimes, but if we see, we have a triangle here, so I'm going to highlight the first triangle in red, okay? And then the second triangle in blue. Do you see that I had a place where the red and blue overlapped? That's when I can use the reflexive property because they share that side. So here it says MN is congruent to NM. They're the same line. So by the reflexive property, I can say those are congruent. I have three things marked: a side, an angle, and a side. And they're right after another. So by side angle side, the triangles are congruent. Okay? All right, let's do another one. So here we go. My givens, I always start with that. So I'm given that AB is congruent to CB. BD bisects ABC. So that's also given. Now we have to think about what bisects means. Bisects means to cut in half. It means to cut in half. So that means if it bisects an angle, it's going to cut an angle in half. So if I look, the angle that it's cutting in half is ABC. Okay, ABC is the angle. Well, the two angles it makes is ABD and CBD. So I said ABD, angle ABD, and angle CBD. And now those are congruent since we bisected. Well, look, that's what it says. Okay, so by the definition of an angle bisector, those two are congruent. Now, remember, once I have two things marked, I need to mark that. So I'm going to erase just a little bit here because it's getting a little messy. So they told me AB and CB, there we go. And then I've just figured out that these two angles are congruent. And once I've ran out of my givens and I've figured things out, then I have to see if I have reflexive or vertical angles. Well, if you look here, they share this side DB. So that means DB is congruent to itself, or BD is congruent to itself by reflexive. And now that I have three things marked, side angle side, these are congruent by side angle side. All right, next one. Our given is that V is the midpoint of WZ and XY. So that's given, and it's two different things. So V here is the midpoint of WZ. So WZ is this line. And what does a midpoint do? A midpoint cuts something in half. So WV is congruent to VZ. Oh, well, look. that's here. So that's the definition of a midpoint. Now, they kind of did this backwards than what I would like it, so I'm actually going to do 4 first. Because XV is congruent to YV, because also if V is the midpoint of XY, that means XV is congruent to VY. And that's also by the definition of a midpoint. Now, for number 4, I've marked 2 things. I ran out of things to mark. And they don't share a side, but maybe they share an angle. Well, the other thing I can look for is vertical angles. And if I look at the red and the blue lines, I made an X. And so this angle is congruent to this angle by vertical angles. It's another thing that I can assume. So angle WVX is congruent to angle YVZ because angle V is congruent to itself. I have 3 things marked. I have a side, an angle, and a side. So by side, angle, side, they're congruent. All right, number 7. Here we go. Given, that's what I start with. Then I'm going to mark HI is congruent to GJ. They told me that. Now, they told me HI is parallel to GJ, also given. Okay, now, I now know that HI is parallel to GJ. Now, remember when we talked about parallel lines cut by a transversal? Well, this is what they're talking about. If we have parallel lines, all of those properties still exist. So since we have parallel lines cut by a transversal, here's my transversal, I've created some angles that are now congruent. So here, I can say that this angle that I've marked in blue is congruent to this angle. Because if we look, okay, do we see the Z that it makes? So I talk about in these, it makes a Z. Everybody see the Z? And anytime in triangle congruence I make a Z, I have, so if I make a Z, I have alternate interior angles. Okay, so those 2 angles, the blue angles are marked, are congruent by alternate interior angles. And that's totally a reason. Okay, so I have 2 things marked. Well, I've used all my givens, so the last 2 things I can assume, remember we can assume reflexive property and we can assume vertical angles. Well, it's obvious to see here that I have here, let me erase a little bit so we can, so let's go back. These are congruent. These 2 angles are congruent. Well, the triangles that I'm looking at, let's look at the triangles. GHJ and HIJ, they share a side. So this is congruent to itself, okay, which this is what that says. So by the reflexive property, because they share a side, they're congruent. I have 3 things marked, so they're congruent by side, angle, side.